This is a NEET 2016 question from rotational dynamics. The problem is like this. A light rod of length L has two masses attached to its two ends. Let us try to draw what he is saying. There is a mass M1, another mass M2 attached to a light rod. This rod is having negligible mass. The moment of inertia of the system about an axis perpendicular to the rod and passing through center of mass. So first of all, I have to identify where is its center of mass is. Let us say here is the point of center of mass. What is the location of that center of mass? I have to identify, right? So let me assume the first one is at a distance from the center of mass. I need to calculate the center of mass taking 1 as a reference, right? Let me take this M1 as a reference. The second length will be at a distance L because that was given for you. So I can write a formula for HCM as we have a formula M1x1 plus M2x2 by M1 plus M2. Being the first one is taken like reference, x1 becomes 0. Second one is at the end of the rod by M1 plus M2. So the location of HCM is M2L by M1 plus M2. This is from here. What I have calculated is HCM. Now if I redraw the diagram, for our understanding, this is M1, this is M2, axis of rotation is passing through XCM perpendicular to the plane. From the first one, that's at a distance of XCM. From the second one, that's at a distance of, as the total length is L minus XCM. Then, what is it L minus XCM? Let me calculate. L minus XCM I have already calculated as M2L by M1 plus M2. M1 plus M2 is LCM. So L of M1 plus M2 minus L2 M2L. So LM1 plus LM2 minus LM2 by M1 plus M2. LM2 gets cancels. So L minus HCM is LM1 by M1 plus M2. Now I know the distance of the first particle and second particle. I want the moment of inertia. Moment of inertia can be written like M1 R1 square is the distance from the axis of rotation. This is the axis of rotation. That is M1 XCM square plus M2, this distance, that is L minus XCM square. Now I know both XCM square and L minus XCM square. XCM is, we have already calculated as M2L by M1 plus M2 whole square. M2 L minus XCM I have already calculated for us. LM1 by M1 plus M2 whole square. Let us simplify this value. M1 M2 square L square by M1 plus M2 whole square plus M2 L square M1 square by M1 plus M2 whole square. M1 plus M2 whole square is common. LCM. What is remaining is L square can be taken common. M1 M2 also can be taken common, right? So L square M1 M2 if I have taken common, here M2 is remaining, here M1 is remaining. One M1 plus M2 one square can be cancelled, then remaining answer is M1 M2 by M1 plus M2 of V square. That's the answer for the problem. So this problem has involvement of two concepts first. He wants he wants the moment of inertia passing through center of mass. So my first aim is to calculate center of mass. So I shall be able to calculate the location of the first particle from center of mass r1 in the m1 r1 square, and location of the second particle m2 r2 square. So I can write a formula: moment of inertia is m1 r1 square plus m2 r2 square. So r1 is nothing but xcm. We have calculated that. R2 is nothing but L minus xcm. We have calculated that. And then I have substituted in this formula and simplified to get the answer. That's how we get the moment of inertia of this problem. Thank you for watching.